This presentation will discuss how to use visualizations to help you determine hypotheses. Today's agenda is straightforward. We will discuss the anatomy of a bell-shaped curve. After discussing its anatomy, we will use what we learned to figure things out about the mean of a data set, how to compare means of different data sets, and how to hypothesize about a correlation. Afterwards, we'll discuss the takeaways for this lecture. Let's chat about the anatomy of a bell-shaped curve. As you can see to the right, the bell-shaped curve is literally a curve shaped like a bell. It is symmetric around its highest point, called the mean. The mean is denoted in APA by the capital letter M. Also, since this is symmetric, we should indicate there's tails on either side of the mean which taper off to zero the further you get away from the mean. Okay, so what? We know about the anatomy of a curve, big deal. What can we do with it? Well, we could do a lot with it, but the most important thing we can do with it is to figure out the hypotheses which match a data set. If we can do that, we can easily state the null and alternative hypotheses. To the right, you see some data. The data plots interview scores against a probability of the interviewee having their resume shredded after the interview. As you can see, the highest point is the mean. The mean is somewhere around 55, 57. You know, if you kind of eyeball it, it's somewhere in there. And this mean can be used to help us tackle this really important research question. An HR person asked the following question: do our interview scores equal the industry expectation of 52%? You know, that's a legitimate question. A human resources person needs to know that they're talking to quality interviewees that may eventually fill slots in their organization. So they should compare their scores against an industry benchmark and think about it. Well, given that research question, the HR guy can ask the following null hypothesis. The mean is not 52%, or M is not equal to 52%. And the alternative hypothesis, the mean is 52%. Now, when you look at this, you have to say, okay, well, we'll conduct the right statistical test to give us the answer to the hypothesis. You know, we'll calculate a p-value and figure whether we reject the null hypothesis or not. But also, we can have a little intuition about our statistics. If we look at the chart, our mean score is around 57, and that's not equal to 52. So there is a very good chance you will reject the null hypothesis after looking at this data and performing the proper statistical analysis. That's why we learn about the anatomy of a bell-shaped curve and use it. We can use what we've learned in the previous slide to compare means or compare two curves. As you can see to the right, there is a blue curve and a red curve. The blue curve corresponds to male participants in a study. The red curve corresponds to female participants in the same study. As you can see, each curve has their own mean. Also, it's noteworthy to notice that the score of 0 is not unexpected. Given this information, we can ask the following research question. Did women outperform men for the zero-error performance test? Well, by looking at the graph, it sure looks like it, doesn't it? Their mean is above 0, and the male mean is below 0. So it sure looks like the females outperform the males. So let's just leave that intuition in the back of our mind. However, we really can't say definitively until we perform a statistical test proving whether females outperform males. And to do that, we need to have the hypotheses. The null hypothesis is the mean for female equals the mean for male. That's basically the statement, both curves have the same mean and neither group outperformed the other. The alternative hypothesis is that the means differ. And by differing, I mean one of the means is greater than the other. In this case, visually, we can see the female mean is higher than the male mean. So if we perform a statistical test and it tells us to reject the null hypothesis, we can definitively say the women outperformed the men for this test because the means are different and the women had a higher mean. We don't have to just compare curves. We can use this same sort of thought process to compare stuff on scatter plots, believe it or not. And when we compare stuff on scatter plots, we end up talking about correlation rather than means. Okay? So let's look at the data to the right. The data to the right plots individual weight versus individual height. And we did this for a number of individuals. Each individual is a dot. So as you can see, as a person tends to be heavier, they tend to be taller as well. Or you can read the graph the other way around. As a person tends to be taller, they tend to be heavier. We can fit this with this best fit line, which you guys might know as regression from Excel, or the best fit line in Excel. And as you can see, as a person gains a pound or so, they gain a little bit of height. Or if they gain a little bit of height, they gain a little bit of weight. And that's not a really big surprise because the taller you are, the more muscle, the more bone, the more skin, the more hair, the more biological tissue you're made up of. So you have to weigh a little more. That's not a really big surprise. So we should expect some sort of correlation to appear. The other thing that gives us a clue about a correlation that should be appearing is the fact that the best fit line has the same number of dots roughly on top as on bottom. That's a really good sign. If you can say, hey, there's roughly an equal number of points above the line and below the line, and all the points roughly follow the line, that is a good indication of a correlation. And since we have a good idea that correlation may be occurring, we can actually start tackling a research question and some hypotheses. The research question is, what is the relationship between a person's weight and height? If you think about it, that's a perfectly logical question to ask. However, the null hypotheses will state there is no correlation between weight and height, while the alternative hypothesis will state there is a correlation between weight and height. Now that we have everything we need, we can actually go out and perform the statistical test and find out whether we reject the null hypothesis or not. My guess is if we perform this test, we will reject the null hypothesis because the chart is screaming that there is some sort of correlation here. And just by visual inspection, we can say, yeah, there's some sort of correlation, but we need to work out the statistics to figure out the strength of the correlation and other important factors involved with correlation. But I wanted you to learn something from this chart, that what we're doing just doesn't apply to curves. It can also apply to scatter plots and other sorts of data sets. So don't be afraid to use this logic to tackle other data visualizations. What should we take away from this lecture? Well, we should take away a whole bunch of things, but here are the big points. Often, a curve or plot of the data can hint at a possible hypothesis test. Remember, if you can visualize it, you can hypothesize about it. It may take a little bit of work, and it might be a little stressful, but you can do it. Every curve has an anatomy. If you understand the anatomy, you'll be able to find the mean. And once you can find the mean, you can really start thinking about things. If the curve is bell-shaped and fairly symmetric, the highest point will always be the mean. But be careful. The curve has to be bell-shaped and fairly symmetric around the mean. You could state hypotheses using words and/or equations. If you noticed, we used both during the slide presentation. There's nothing wrong with that. That's okay. And last but not least, we covered a whole bunch of ideas and a whole bunch of stuff and a whole bunch of tips and tricks and insight and other things that helps you convert the visualization into a statistical test. That can be kind of rough the first few times you do it. So ask questions. If you're stuck, you need help, whatever, come to forum, ask for help. We can help. That's why we're here. I hope you learned a lot from this presentation, and good luck on your project.